Hello, this is Filipino explaining the duality concept, or the concept of duality. So let's learn, to be specific, let's learn how to convert a primal LP problem to its dual. For example, can be given example can be given LP problem like this. In its primal, maximize z is equals to 8x1 plus 3x2 plus x3 subject to x1 plus 6x2 plus 8x3 is less than or equals to 118. x1 plus 5x2 plus 10x3 is less than or equals to 240, and x1, x2, x3 are greater than or equals to 0. So solution: what is the first step that we should take to solve this problem? The first step is to convert this LP problem in primal form to its standard primal, LPP problem, to standard primal LP problem. And how can we do this? We can say step 1, convert primal to standard primal. So you can say that maximize, I just copying the here, 8x1 plus 3x2, or z is equals to this, sorry, plus x3, and you can call this equation 1. Then this here subject to this x1 plus 6x2 plus 8x3 is less than or equals to 118, and x1 plus 5x2 plus 10x3 is less than or equals to 40, will give rise to other two equations. Each will give rise to other two equations. This is what I mean. For example, x1 plus 6x2 plus 8x3 is less than or equals to 118. So this will give rise to two other inequalities. Say here, just copy to give rise to x1 plus 6x2 plus 8x3 is less than or equals to 118, and it will also give rise to x1 plus 6x2 plus 8x3. Now here it is greater than or equals to 118, but they will multiply the whole of this by negative 1. Now with there, which will give us negative x1 minus 6x2 minus 8x3. So if we multiply this negative 1 times this with the whole of this inequality, this will change and will be less than or equals to negative 118. Hope you are there. So this is equation 3 4 equal to 3, here 4. Sorry, it's 2, 3, sorry for that. It is 2, here 3. We do the same with this x1 plus 5x2 plus 10x3 is less than 8 or equals to 240, is less than or equals to 240. So give rise to the other two. The first one, we just copy this x1 plus 5x2 plus 10x3 is less than or equals to 240, and the other one is x1 plus 5x2 plus 10x3 is greater than or equals to 240. By the whole of this we multiply -1. Are you seeing? So that you have negative x1 minus 5x2 minus 10x3. Now it changes the sign. It's less than or equals to negative 240. This becomes 4. Then this becomes 5. Are we there? So the standard primal problem, standard primal LP problem will be, now we just write this, just write this there, just copy this, maximize z is equals to x1 plus 3 x2 plus x3 subject to number 2 is x1 plus 6x2 plus 8x3 less than or equals to 118. Then 3 is negative x1 minus 6x2 minus 8x3 is less than or equals to negative 118. 4 is x1 plus 5x2 plus 10x3 is less than or equals to 240. Then 5 is negative x1 minus 5x2 minus 10x3 is less than or equals to negative 240, and x1, x2, x3, remember it's here, just copy this now. Are you getting what I'm saying? Is greater than or equals to 0. So the dual, you want to change, convert now this to dual. Remember, our ultimate goal is to convert this primal LP problem to its dual. Now we have converted it to standard primal LP problem. Remember, from primal to standard primal. Are you getting? Now we want to convert this into dual LP problem. So when converting the dual, I can just write here first that the dual of this given, the given primal LP problem is So when converting to dual, we transpose row and column of constant coefficients. I show you how to do that. We transpose the row and column of constant coefficients, then we change the inequality from this less than or equals to greater than or equals to, then minimize the objective function instead of maximizing. Remember, here we have this, the objective function, maximize z something, so we will have minimize z something. Are we there? So I've said that the first thing you transpose row and column of constant coefficients. So here, see what I'm doing. So we have said that we transpose, then we change the inequalities, then we minimize the objective function instead of maximizing. So with the transpose one columns, so the objective function will be minimize z is equals to, out there, is equals to, so are you seeing this? We put them here. These are the row. This column will be the row on the first. This column will be the row on the first, but we can use another letter instead of x. So we'll have minimize z. So this will be here. Have 118. Can use another letter like w. W1 minus 118. W2 plus 240, W3 minus 240, W4. Are we there? So we are done with the objective function. The objective function, we have minimized instead of maximizing, and then we have transposed the row and column of constant coefficients on the objective function. So let's transpose the rows and columns for this part. Subject to, so these rows will be the columns. Are we there? And this row will be the column, and this column will be the row. So we have x1, this is the first row. Now since this is the first column, it will be the first row here, so it will be x1, not x, we have said that we are using w1, it will be w1 minus w2, remember we are moving this way, plus w3 minus w4, and we have said now we are changing this from less than to equal, less than or equals to greater than or equals to. Are we there? So greater than or equals to. Now we shall use this using the ones that have been on the objective function. This, remember, is a row, now will be a column here. Have moved this to this, now we are moving this. Are we there? So the first one will be 8. Are we there? Then we are moving to the second column, which will now be the second row. It is 6w1 minus 6w2 plus 5w3 minus 5w4 is greater than or equals to, now this one, 3. It's greater than or equal to 3. Then the third column will be, now the third row here is 8w1 minus 8w2 plus 10w3 minus 10w4 is greater than or equals to, since we are having 1, that's x3, that's 1, see 1 here, and and w1. Here it's x1, x2, x3. Now we have w1, we have w2, w3, and w4 is greater than or equals to 0. This one does not change, right? This sign does not change. And that's I think that's the answer. Or we can also write in this way: minimize z is equals to, we factorize this, 118 w1 minus w2 plus 240 w3 minus w4. I'm just factorizing that, but we cannot, it's not a must. Subject to w1 minus w2 plus w3 minus w4 greater than or equals to 8, then 6 w1 minus 6 w2 plus 5 w3 minus 5 w4 greater than or equals to 3, then 8 w1 minus 8 w2 plus 10 w3 minus 10 w4 greater than or equals to 1, and w1, w2, w3, and w4 greater than or equals to 0. The same thing as here. You can leave it at here to here. Now this is the dual of the given LP problem. This is its dual. Are we there? Thank you so much for watching. Yeah, you can just suggest a video of which you can finding difficulty on a topic. You can say a topic, then I can create a video for you to help. This is the concept of duality in operations research. Thank you so much. Till next time. Bye bye.